The next part says the worker pushes the wheelbarrow 2 meters along the plank. Calculate the work done on the wheelbarrow by the worker. Now work done is force multiplied by the distance moved in the direction of the force. And we can see that the force being exerted by the worker on the wheelbarrow is 290 Newton, and the distance covered in the direction of the force is 2 meters. So we are going to use these two values. It would be 290 multiplied by 2.0, and it gives 580 joules as the answer. So the work done is 580 joules here. Question number 2. It says the total mass of a wheelbarrow and its load is 90 kilograms. So this is the total mass of this wheelbarrow and the load placed in it. A worker pushes the wheelbarrow and the load up a plank of length 2 meters. So the length of this plank is 2 meters onto a platform as shown in figure 2.1. The platform is at a height of 0.60 meters above the ground. So this is the height of the plank, which is 0.60 meters above the ground. The worker exerts a force of 290 Newton on the wheelbarrow in the direction in which the wheelbarrow moves. The gravitational field strength G is equal to 10 newtons per kilogram. Calculate the gravitational potential energy gained by the wheelbarrow and its load. Now the gravitational potential energy is given by the formula GPE is equal to mgh. So the mass of the wheelbarrow is given to be 90 kilograms. The value of G which is to be used here is 10, and the height, the vertical height the wheelbarrow is gaining and the load is gaining is 0.60 meters. So the value of H to be used here is 0.60 meters. And when we multiply these values, we get the answer as 540 joules in two significant figures. So the energy gained by the wheelbarrow and the load is 540 joules. The next part says the worker pushes the wheelbarrow 2 meters along the plank. Calculate the work done on the wheelbarrow by the worker. Now work done is force multiplied by the distance moved in the direction of the force. And we can see that the force being exerted by the worker on the wheelbarrow is 290 Newton, and the distance covered in the direction of the force is 2 meters. So we are going to use these two values. It would be 290 multiplied by 2.0, and it gives 580 joules as the answer. So the work done is 580 joules here. Suggest one reason why the answer in previous part is not equal to the answer in the first part. Now both parts are giving a different answer. The work done by the worker is 580 joules, but the gravitational potential energy gained by the wheelbarrow and its load is 540 joules. So there is a difference of 40 joules, which is being noted here, that the work done was 40 joules greater than the gravitational potential energy gained by the wheelbarrow. So why is it different? One answer could be that work done against friction is the reason of this difference. So there is friction between the surfaces, and for overcoming that friction, some work done or the energy would be used. So that is why that much work done would be used to overcome the friction, and the remaining work done would be used to increase the gravitational potential energy of the wheelbarrow and the load. The worker finds that walking up the plank pushing the wheelbarrow is even more inefficient than answers in part A. Suggest what is meant by efficiency. So the definitions of efficiency is to be written here, and it is the ratio of useful output energy to the total input energy. And if I try to write it in the form of a formula, then efficiency would be equal to this ratio, where useful energy output would be written in the numerator and total energy input is to be written in the denominator. And if we want to convert it into percentage, then it would be multiplied by 100% over here. Suggests one reason why this method of lifting the load onto the platform is so inefficient. So one of the reason is that the main purpose is to lift this load, and when the load is being carried in a wheelbarrow, such a massive wheelbarrow, then the wheelbarrow uh, would also be needed to be lifted over the plank. And similarly, when some human being is lifting this arrangement or moving this arrangement, then his own weight is to be carried over the plank. So there are two massive extra objects being needed to be carried over the plank. One is wheelbarrow and one is this lifter or the worker. So this method requires a lot of input energy, and it is so inefficient that along with the load, there are two main objects or massive objects which are to be lifted. So one reason could be that wheelbarrow and the worker also are to be lifted